Hello, guys. Let's talk about solutions. And this time, I'm not going to bore you with my favorite joke about solutions and chemistry, but jump right into what is a solution. So, you already probably know that it is a homogeneous mixture of two or more substances. And we can vary the composition of a solution until it is uniform throughout the mixture. So, for example, if you have a cup of tea and you want to add more sugar to it, you can do that by adding more of the solute, which is the substance that is being dissolved, the sugar in this case, in the solvent, which is the tea in this case. Okay, and you can add as much sugar as you want until it doesn't dissolve anymore. So it becomes a heterogeneous mixture. Okay, I hope this makes sense. So, what are the types of solutions that we have to know about? Well, it depends on how much of the solute you have. We can have unsaturated solutions which contain less than the maximum amount of solute, so you can add more and more sugar into your tea and it's still going to dissolve. The saturated solution is going to contain the maximum amount of solute. This means that if you add more sugar into your tea, it's not going to dissolve anymore. And there's a third type, which is a little bit weird. It's called supersaturated solution, which contains more than the maximum amount of solute. And you may ask, how is that even possible? Well, what do you think? Sugar dissolves better in a cold or a hot tea? In hot tea, right? So this means that with increasing temperature, most substances, which are solids, are going to dissolve better in the solvent. So similarly, we can take sodium acetate, which is an ionic compound, and we can dissolve it in really, really hot or boiling water. And then we can let it cool down. And if you don't touch that solution at all, you are going to end up with a solution that contains more than the maximum amount of solute possible. Check this video out right here. So we have a nice homogeneous solution here, and we can take a scapula and we can just touch it a little bit. And then let's just see what happens. Wait for it. There it is. The crystals start forming. So, because we have more than the maximum amount of sodium acetate in this solution, it's going to actually crystallize inside the solution, forming these beautiful crystals right there. Okay, so that is a fun experiment. Now, let's move on to solubility. So, solubility is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. So, concentration is going to be very important in this topic. But why do things dissolve? Well, this is because the solute particles, they can be molecules or ions, interact with the particles of the solvent. Let's just take sodium chloride table salt dissolving in water. So I can write out the equation for it. So I have NaCl, which is a solid, and I mix it together with water. What will I get? Well, I'm going to get Na plus aqueous ions and chloride ions, Cl minus aqueous. But what happens in the process? So let's say this is our NaCl with the purple little spheres being the chloride ions and the green little spheres being the sodium ions. And we know that water molecules are polar, so their hydrogen side is going to have a partial positive charge and their oxygen side is going to have a partial negative charge. This is due to the electronegativity of oxygen, and oxygen pulls towards itself the electrons from the hydrogen atoms, creating the partial negative charge on the oxygen side. So the water molecules just kind of lingering around, and then they're like, hey, there's a charge. I might like that charge. So the water molecules pull the different ions, the chloride and the sodium ions, away from the crystalline structure, creating ion dipole intermolecular interactions. And at the end, you are going to end up with the chloride ions surrounded with the water molecules with their hydrogen atoms facing towards the negatively charged chloride ions. And the sodium ions surrounded by the water molecules with their oxygen side facing the sodium ions. Okay, so what happens if we have molecular compounds, just like methanol? So methanol is shown right here, and it has the formula of CH3OH. This is the hydrogen atom, this is the oxygen atom, carbon, and these are the three hydrogen atoms. Can it do hydrogen bonding? Yes, it can. So if it has a water molecule around it, it will be like, hey, water molecule, can I do some hydrogen bonding with you? And it's going to do that. So the oxygen side is going to orient itself towards the hydrogen side of the OH part of the methanol molecule, creating hydrogen bonding between the two different species. Now, what happens when water molecules meet with nonpolar compounds like CCl4? And this is right here. So in carbon tetrachloride, we do not have hydrogen bonding, right? This is a nonpolar molecule. So basically, carbon tetrachloride will not dissolve in water due to the hydrogen bonding between the water molecules, because the water molecules will be like, hey, I can hydrogen bond with my other water molecule friends, but I cannot do that with you, so sorry, I'm not gonna mix with you. But we can summarize this in a very simple rule. And the rule is like dissolves like. So this means that when we have nonpolar compounds, they are going to dissolve in nonpolar solvents. And when we have polar or ionic compounds, they are going to dissolve in polar solvents. And we know that water is a polar solvent. Liquids that are going to mix in all proportions are going to be called miscible, and liquids that do not mix in one another are going to be called immiscible. So mixable liquids are methanol and water, and immiscible are carbon tetrachloride and water. Okay, so let's do a couple of practice questions. Which one of the following substances is more likely to dissolve in carbon tetrachloride? So we already know that CCl4 is nonpolar. So we need to find in the list the other compound that is also nonpolar. So let's go step by step. We have first here ammonia, NH3, right? And we know that it's actually going to be capable of hydrogen bonding, right? So definitely going to be a polar molecule with the nitrogen side having a partial negative charge, so it's probably not going to mix well with CCl4. What about HCl, hydrochloric acid? So I draw this out. You are going to see that there is one bond between the two atoms, and it's actually going to be a polar bond, so it's again a polar compound. Then we have NaCl that contains Na plus and Cl minus ions. Again, it's highly likely that it's not going to dissolve in CCl4 because it is an ionic compound. Then we have methanol here, which obviously has the OH group, which is capable of hydrogen bonding. So it's definitely going to be a polar compound and will not mix well with CCl4. What about C6H6? So this is benzene. This has a really cool structure. Looks like this. And each hydrogen atom is connected to one carbon atom in here, and we are going to have double bonds here that can move around. I hope you remember this compound. So this is going to be a non-polar organic compound, and this is going to dissolve in CCl4 pretty well because it is a non-polar compound. So simply when you are talking about a nonpolar compound, what will mix with it well? Well, the other nonpolar compound in the list. Now, what is our other question? Which one of the following substances is more likely to dissolve in CH3OH? Methanol again. So we know that this is a polar compound. So we need to find in the list the other polar compound with which it's going to mix really well. So we have H2, which is a diatomic element, right? It's nonpolar. This is how it looks. We are going to have CF4, which has a tetrahedral geometry, just like CCl4, and is going to be again nonpolar. We just talk about C6H6, which is again benzene and nonpolar, but we have ammonia here, which is nice and polar, and it's actually going to be able to do hydrogen bonding with the methanol molecules. So they are going to mix really, really well. All right, what about krypton? Well, we are only going to have London dispersion forces between krypton atoms, right? So it's probably not going to dissolve really well in CH3OH. All right, one more question. Which one of the following is most soluble in benzene, which is nonpolar, and which one is most soluble in water, which is polar? And we have a list of organic compounds which have one, two, three, four, five, or six carbon atoms. So basically, the carbon chain gets longer and longer with each compound. Although in each of these molecules, we are going to have an OH group, but because the carbon chain increases, as it increases, the molecule itself is going to become less and less polar. So, in order to dissolve in benzene, we have to find the least polar molecule. And it is going to be the one with the longest nonpolar part, which is the last one right here. So this molecule is going to dissolve really well in C6H6 compared to all the other molecules before because it has this long non-polar carbon chain. So now, which one will be the most soluble in water? What do you think? The one with the smallest amount of nonpolar parts, which is methanol CH3OH. So overall, that molecule is going to be the most polar in the list and going to dissolve the most in H2O. All right, I hope this makes sense. See you in the next video.